Welcome to the video for 5K and 5L linear tables. So our first objective, I can determine if a table represents a linear function. So let's look at that first and then we'll come back to 5L. So does this table represent a linear function? And we have a couple tables here and we're going to figure that out. You can either plot all the points, and see if they form a line, and our OR situation is going to be below. But let's start with plotting the points and see if they form a line. All right, well, our coordinate plane here doesn't really go up far enough for us to plot many points. Let's go ahead and change these numbers here on the y-axis by 2's. So we'll actually make this 2, 4, 6, 8, 10. That'll at least get most of our points here. All right, so 0, 0 is right here. 1, 1 is here. 2, 4 is here. 3, 9 is here. And you'll start to see, we need a few points to actually see what's going on here, but it is curving. It's not a straight line. So this one, it does not form a line. It forms this curve here. So this is going to be no. How about this one? Again, we don't have enough points here. If we go by 2's, we're not going to get high enough. So let's go ahead and change this and make it by 5. So 5, 10, 15, 20, and 25. We'll get them all on there. All right, 0, 6 is going to be right about there. Then 1, 10. Then 2, 14. 3, 18. And 4, 22. If you did a pretty good job of plotting your lines, you should, or I'm sorry, your points, you should see, whoops, this does form a line here, even though I can't draw straight. It does form a line. So one way you can find out if a table is linear is just plot the points and see if it forms a line. But let's say we don't have a coordinate plane there for us. Another way, or you can find the change in output between consecutive inputs. And then when the difference between consecutive inputs is constant, so changing at a constant rate, and consecutive inputs is also constant, it's a linear function. So most of the tables we're going to be working with in this unit are just going to go up by 1's. And if you just look over here, this change is just going up by 1 each time. Okay, but as long as you're just seeing 0, 1, 2, 3, 4, 5, you don't even have to draw this or check. Now on the right here, we're going to see how much it changes by each time. So what's the change here? And we're going to make another column with delta, and this triangle means delta or change. And we're going to see what do we need to add or subtract to 0 to get to the next number here. So 0 plus 1 would give us 1. 1 plus 3 would give us 4. And 4 plus 5, and then 9 plus 7. Okay, if you don't see a pattern on this first one right here, it is not a linear function. So this is just the same as the one as we did above, right? We already determined it's not, but just to show you the same thing with the table, this is not a linear function. Okay, coming over here, our ends are just going up by 1. 1, 2, 3, 4, or 1, 2, 3, 4. Let's make another column to find the change and what it's going up by. Well, to go from 6 to 10, I would have to go 6 plus 4 would give me 10. 10 plus 4 would give me 14. 14 plus 4. So this is what I'm talking about when we want to see a constant change. Because we have each out is going up by the same number, this would be a linear function. Okay, coming here, Find the output if the input is 20. So what we're going to want to do here is first find out if it's a linear function, because if it is, then we can write a linear equation and then find that output. So let's see what this is going up by making a delta column. And if there's a pattern, or they're all the same, it's a linear function. So 3 plus or minus what is going to give us 8? Well, 3 plus 5, so let's put a positive 5 there, gives us 8. 8 plus 5 gives us 13. The whole way up, except I do have a typo over here, so we're going to fix that. So 23 plus 5, we're going to make this 28. I do want this to be linear. I just typed it in incorrectly. And then 28 plus 5 gives us 33. Okay, so we want to find out when the input is 20, what's the output? And we could continue our table, but that's not always the most efficient way to do these things, especially if you have a number that's pretty high up. So let's think about what's happening on each of these. Okay, on this top one, we just start off with 3. When we get to the input of 1, we're doing 3 plus 5 to get there. When we get to the input of 2, we're doing 3 plus 5 plus 5. So the above 2 5s is going to give us that. When we get to 3, we're doing 3 plus 5 plus 5 plus 5. We get to 4, it's 3 plus 5. You can start to see a pattern here, hopefully, plus 5 plus 5 plus 5. All right, well, what is repeated addition? This first one's just 3. But then after this, 3 plus 5, what's another way? Oops, I didn't mean to write that there. What's another way to write 3 plus 5 plus 5? Well, we could go 3 plus 2 times 5, and 3 plus 3 times 5, because we have 3 5s, and 3 plus 4 times 5. So hopefully something's becoming familiar here. We have something being multiplied together and then added. Well, this looks a little bit like y equals mx plus b. So what's the slope? Well, what's the change in y over x? If these are y's, so we're changing 5 each time, and x we're changing 1. The slope for this table will just be 5. What's the y-intercept? Well, we're looking for, and just to give you a visual of that, we're looking for the point where our line is going to cross the y-axis. And that point is always where x is 0, because we're not going anywhere on the x-axis, so it's where x is 0. So our y-intercept, well, when we look at our table, is where x is 0. So 3. So if we come back here, the thing that's changing each time that we need to put in for our variable is our x. Okay, so that's where this y equals mx plus b comes from. So if I just take one of these, all this is 3 plus, this part's changing, so we'll call it x, times 5. And if we want to rewrite it so it's in y equals mx plus b form, or even better function notation, f of x equals 5x plus 3. Okay, so all of this was just to show you how the table relates to the linear function. But all you need to do when you're actually writing the linear function is to figure out what the change in y is by making this column. And like I said before, we're going to mostly go up by ones for this unit. But if you're going up by a different number, you'd find the change in x, put them over each other, and then figure out where 0 is on your chart. And that would be the y-intercept right there. All right, so we still haven't answered our question. Find the output if the input is 20. Well, now we have a linear function, so we're just going to plug in 20 equals 5 times 20 plus 3, and we get 103. So our second objective up here was just that. I can find the output for any given table and write a linear function given a table. So let's try a few problems like that, or at least finding the linear function. So write the linear function for the following tables. If not possible, explain. So let's first see what the change is on this. So to go from 0 to 3, I'm going to add 3. From 3 to 12, I'm going to add 9. And already I can see that there's not a constant change. From 12 to 27, I'm going to add 15. So it's asking specifically for a linear function. Yeah, there's other functions, but since it's asking for a linear function, it's going to be not possible because it's not linear. All right, let's try the next one here. From 10 to 7, we actually have to subtract, so we're going to make this a negative 3. Then from 7 to 4 is also negative 3. And as we keep going, we can see that it is negative 3. So we can go ahead and write our function, f of x equals negative 3. This is changing by 1 each time. So just negative 3 over 1 would just be negative 3. Multiply it times x, and then find the y-intercept, and that's where x is 0, so right here. So add 7. Okay, let's change this one because I made yet another typo. Sorry, I was rushing through this, but I want to prove a point here. So we're going to make this all 3's. So from 3 to 3, we add 0. Each time, we're adding 0. So is this a linear function? Yeah, it is a linear function. The change is just 0. Remember, we can have repeating y's. That's okay. So let's write it how we were writing it before. So our change in y over our change in x would just be 0 over 1. And 0 over 1 we can do. 0 over 1 is fine. That's 0. Remember that 1 over 0 is a problem. That's undefined. But 0 over 1 is 0 times x plus 3. Well, 0 times x is just 0, so our function is actually f of x equals 3. This is a function. This is the same as y equals 3. And if you remember, if we want to graph this, hoi, so a horizontal line at 1, 2, 3 is right here. This is a line, it is a function, and it's the function y equals 3 or f of x equals 3. And if I look at these points, 0, 3, that's on the line, 1, 3, that's on the line, 2, 3, so it does form this horizontal line here. All right, last one we're going to do together here. Let's find our change. Well, each of these is going up by 1,500. So while these are big numbers, we can still certainly put them in a function. And it is certainly linear, so f of x equals, my slope is 1,500 times x, and now I need where y is 0. Well, we're not given where y is 0, but if going this way, I have to add 1,500 each time. If I wanted to go up 1 and make 0, then 31,500 minus 1,500 would give us 30,000. So our y-intercept is 30,000. All right, that's it. Thanks for watching, and please write any questions you have below so that way I can answer them in class.